All right, for section 12.5, what we'll be doing is using all the methods that we've learned to solve quadratics, and you'll get to choose what method you've learned. The first that you want to use. The four that we've learned is using square roots, which means taking the square root of both sides. That's usually the simplest way if you can use it. We've learned about factoring. This is usually a good idea just to go ahead and take a quick peek at the problem. Can I factor this? If I can, go ahead and do it. It's usually a quick way to solve. If not, then move on to another method. Then we learned about completing the square. And you're always welcome to complete the square if you like that method of solving quadratic equations. You definitely need to know how to do that method, but you don't have to use it all the time. And then the last one, when you have an option, is the quadratic formula. And so one of these four methods will solve any quadratic equation. And some of them are a little bit better than others, but you don't have to necessarily pick the right one. You can use whichever one that you want to use. So some examples, we're just going to practice this. Looking at this first one, you got 5x squared plus 23 equals 263. This is one of those where taking the square root should jump out of you as the best way to do it, and that is because there is no x term. You have an x squared term, you have some constants, but no x term. So whenever this comes up, you just solve for the x squared, and it's usually the best way to do it. So you do minus 23 minus 23, that gives you 5x squared equals 240. Divide through by 5, and you get x squared equals 48. Take the square root of both sides, and so that gives you x equals plus or minus the square root of 48. And remember, when you're doing these, I want you to do two things always, and that is first, whenever you take the square root of both sides, you always do plus or minus. And then the second thing is leave answers in simplest radical form unless it tells you otherwise. So the square root of 48, 16 goes into 48, and so you get 4 root 3. So 4 root 3 and negative 4 root 3 both solve this equation. And yeah, it's pretty easy to show that because 4 root 3 squared is 48. 5 times 48 is 240. Plus 23 is 263. Okay, for the second one, just a basic trinomial, you can choose, do I want to try to factor this one? I usually look and see if I can factor it just really quickly. You don't have to. You can jump right into completing the square or quadratic formula. I'm going to try to factor it. And so when I try to factor it, I get 3x and x. I can either do 6 and 1, which clearly is not going to work, or 2 and 3. And so 2 and 3 does look like maybe it's going to work. If I do plus 3 here, that gives me 9x. And then minus 2 gives me negative 2x, which does give me that middle term of 7x. And so, yes, this is a factorization of that. And so that means I can go ahead and solve this way. And so I know that 3x minus 2 has to equal 0. And so that gives us a solution of x equals what? 2/3 when you add 2 and divide by 3. And then that one is going to be negative 3. So your two answers are going to be 2/3 and negative 3. Remember, when you're solving a quadratic, you should be expecting two answers. All right, for the third example, if you have a problem like this, well, this isn't a quadratic yet because we don't see the squared term, and so we do need to go ahead and simplify this. And so to do that, for a problem like this, the easiest way to do it is just think about it as cross multiplication. So 2x minus 1 times x plus 4 equals 4x minus 1 times 3x plus 2. And so then we have to go through and simplify all this out. And so that's going to give us what? 2x squared plus 8x minus 1x is 7x minus 4. This one's going to be what? 12x squared plus 8x minus 3x is 5x minus 2. Now I move all these terms over here. So subtract 2x to get 10x squared. Subtract 7x to get negative 2. Add 4 to get positive 2. Now we get to decide, do I want to try to factor it? If you try to factor this one, it's not going to work out well. Do I want to use quadratic formula or completing the square? For me, quadratic formula is the one here because I usually wouldn't consider completing the square unless I've already got a 1 in front of the x squared term. Now, anytime that all of your terms have the same thing, because this equals 0, you can divide through by a common factor. So we can divide this through by 2 to get 0 equals 5x squared minus x plus 1. Now apply the quadratic formula, and so you get x equals 1 plus or minus the square root of b squared, which would be 1 minus 4 times 5 times 1 all over 2 times 1. Remember, here's your quadratic formula. Write it down until you know it. Right, negative b, the b value is 1 here, or negative 1. So negative of a negative 1 is the positive 1. Negative 1 squared is 1. That's that. 4 times 5 times 1. Be careful of your negative sign inside there. All right, so now we simplify, and what we realize is inside that radical, our discriminant, b squared minus 4ac, turns out to be negative 19. Whenever it's negative, we have an imaginary solution, and so no real numbers, and so our answer is no solution, or no real solution. All right, for 4, this one, sometimes there are ways to do this where you can kind of, without having to expand it, but remember that you can always just expand something like this out and then apply the quadratic formula or completing the square or factoring or something like that. So let's just do that. That gives us x squared minus 2x plus 1 plus 3x plus 6 minus 7 equals 0. So x squared plus x. And in this case, it turns out that we get 1 plus 6 equals 7 minus 7 is 0. And so you just get x squared plus x equals 0. Well, this is an easy one to factor, because when you factor, you end up with x times x plus 1 equals 0. So x either equals 0 or negative 1. And then you can kind of check yourself real quick. Put 0 in, you get 1 plus 6 minus 7. That does equal 0. Put negative 1 in, you get negative 2 squared is 4. Plus 3 minus 7 does equal 0. And so your two solutions are 0 and negative 1. And then there are a couple problems at the end that look like this, where they're quadratic-like. And whenever you have those, what you want to do is apply a technique, but you need to do a substitution first, which our substitution is x squared equals y. And so we rewrite this as y squared minus 6y plus 8 equals 0, which factors very nicely to y minus 4, y minus 2 equals 0. So y equals 4 or 2. Now, that's not the answer. 4 and 2 are not the answer. If you plug 4 and 2 in here, you don't get a solution. Instead, we get that y equals 4 and 2. So that means x squared equals 4 and x squared equals 2. So x is going to equal plus or minus 2. Take the square root of both sides. And take the square root of both sides, plus or minus square root of 2. So it turns out there are 4 solutions, those 4 numbers, to this equation. So you make your substitution like this, solve it, then substitute it back into this and get square root. If you get a kind of you have to use quadratic formula and get an ugly radical, then it can get pretty ugly unless you can make it a decimal and just estimate your answers along the way.